There we go. Is that better? Look at us go. Okay. And look, it only took us 12 minutes today. It took us like 30 yesterday. So yay. Okay. So we'll definitely get through 2.1. Again, don't worry, if we don't get to 2.5 and don't get through all of 2.5, chapter 3 tomorrow is short. Won't take us very long, okay? A lot of it, again, is that shifting, so it shouldn't take us very long, even though there are lots of pages. Are you ready? Get it. Okay. So first thing we're going to talk about is functions. I'm going to go to the next slide. Okay. So we talked about functions and what it is, right? So let's see if I can do this. It's a relation. Oh, I lied. It's a correspondence. Y'all, I'm a mess. Okay. It's a Y'all, I can't. With my life. Okay. The poor Zoom people can't even see it. The correspondence between two sets. Right? For every X, you've got a Y. It's a set. Okay? The relation is that correspondence between those two sets, your set of X and your set of Y. If X and Y are two elements in these sets, and if a relation exists between them, then we say that X corresponds to Y, or Y is dependent on X. Correspondence between two sets is the first line. The second line is corresponds. The third line over here is depends. And we can write it by saying X, arrow, Y. Okay? If I have an X, I can figure out Y, right? Your Y is always dependent on what X is. Okay? We can express relationships in different ways. One way we can do it is by equation. Okay, an f of x, right? Function of x. We can also do it on a graph. Oops. Graph. Okay. How else can we do it? What is it called when I have x and y in parentheses?
Points.
No, ordered pair. Ordered pair. Or we can say we can map them. Okay?
That's the last
All
one.
different ways, huh?
That's the last one. No.
That's the last one. What are the 4 ways to express relations between two sets? Okay? We can write it as an equation. We can see it on a graph. We can come by it through ordered pairs, right? Your X and Y, they're ordered. Or we can do it by a map. Okay? We can do the next slide. When we say map, what we're kind of talking about is a graphical representation that's not necessarily on a graph. Look at me.
Oh no.
Oh no. There we go. Cool. Okay. This is a map. Okay. See how it's not a graph, but it's still a picture representation? I mean, it kind of to me looks like little like amoebas or something weird, right? Going on like little cells. Right? Yeah, exactly. Okay. So X and Y are two sets, non-empty, there's stuff in it. Okay, that's all that means. A function from X into Y is a relation that associates with each other, with each element of X, how many values of Y? If I have an X and it's a function, how many Y's can I have? One.
One.
Exactly. One. Right? That's what makes it a function. Does that make sense? Mm-hmm. Here, we've got our amoeba of X's, right? Here, we've got our amoeba of Y's. For each x, there is one and only one value for y. Otherwise, it's not a function. Okay? No input has more than one output. If I were to say to you, Professor Gentry's got 4 different phone numbers, right? Got a house, got a cell, got an office. I lied, I have 3. Okay? Is that a function? No, right? Because I have 3 different choices for my phone, right? Now, if I say Professor Gentry has 1 job, is that a function? Right? Given 1 person, there's 1 job associated with it. Okay, you see the difference there? The domain of the function is going to be your set of x. Okay, and then on the opposite side, your range is your set of y. Okay, domain is your set of x, your range is your set of y. X and y, right? You graph it, x, y. Okay. Sorry, Mary Mac looks at me like I was crazy. I mean, I am, but it's fine.
I was about to say.
Okay, does that make sense? So we now know what domain and range are, right? Okay, next slide. Okay. Yeah. I don't like this little pedestal up here. It's like not quite big enough. I feel like I'm gonna fall off. I don't like it. I don't like it. If I fall, y'all just make sure I'm okay before you laugh. Is that cool?
I'm a video.
Okay.
I'm a send it to AFC. We're gonna get lost.
I'm done. Okay. Determine which of the following relations represents a function. If the relation is a function, state the domain and range. So here, the first one is the boxes. Okay? If I say my level of education is my x and my unemployment rate is my y, is that a function?
Yeah.
Yes. Okay. Why?
Because they each have 1.
They each have 1. If I were to take this high school diploma and point it up here also to 7.7, would that be a function now?
No.
No, I just killed my function, right? Okay. So B, a set of ordered pairs, right? We've got 2, 3, 4, 1, 3 minus 2, 2 minus 1. Is that a function? Mary Mac says yes. Why?
Because they all.
She's like, I don't know. No, I'm just kidding.
I mean, I really don't, but they all have 1, like each x. Oh, JK, it's not. What? Actually, yes, it is, because the x's can have. If can't.
So what are my x's?
Your x's are 2, 4, and 3.
What are my y's?
Your y's are.
3, 1, -2, and
I was trying to do it in order.
Okay.
Give me a second.
My 2 goes to a 3, right?
Okay, but.
My 4 goes to a 1.
Yes.
My 3 goes to -2.
Yes.
My 2 back up here also goes to -1.
It's still.
Is that a
though,
function?
right? Can that still be a function? Okay.
Well, what did we say here? Here, when I duplicated my x for high school diploma, we said it killed my function, right? So this has 2 x's having, 1 x has 2 different y values. Does that mean it's a function or not?
No.
The way you're explaining it makes me want to say no. I'm gonna go with no.
Okay, but do you know why?
Because the x has.
Your x's have to be unique. They can only have 1 y associated with it. You can duplicate the y's for different x's. You cannot duplicate the x. Hey, when did you sneak in?
For a while.
Mhm.
He's asking me for a while.
You guys are funny. Okay, does that make sense?
Yeah.
Yeah. Okay. What about this set down here? -2, 3, 4, 1, 3 minus 2, 2 minus 1. Yeah? Why? Right. Every x is unique. They each have 1 y associated with it, right? Okay. Now, so let's look at C. If I was going to look for the domain of C, what would that be? What values are the domain?
-2, 2, 3, and 4.
-2, 2, 3, and 4. Perfect. Right? My x's, right? My domain. What about my range? -2, -1, 1, 3, question mark? Putting them in order? Okay. The range is just the y's. What y's do you have? Right? Make sense? Kind of. Ooh, she said definitely. Woo. Okay. Heck yeah. Okay, what about D here? I've got 2, 3, 4, 3, 3, 3, 2, 1. 2 minus 1, I'm sorry. Is that a function?
Oh my God.
I gotta know. Anyone else want to say no? She's gonna go with no. Anyone else? Come on, boys. What is it? Yes, no.
I'm still on C.
He said he's still on C. Okay? It's not. Do we know why?
Because there's 3, 2, 2.
Yeah, you used the number 2 twice for x, right? There are 2 different y's associated with that x. Okay, so it's not a function. Does that make sense?
Mm-hmm.
Yeah? Okay.
Not a function, but it doesn't repeat the same.
Next.
But this is repeat.
Example number 2, I believe is next. Here we go. Determine whether a relation represents a function. Okay?
The domain is the x.
So the first one for A. Oops. For A. Y equals -1/2 x minus 3. Is that a function? Yeah? Okay, why is it a function? You don't know. You're just guessing. Okay, why is it a function?
Can't tell you right now.
Can't tell me that. Okay, lovely. I cannot with him.
Because is it just because there's just the one y for that x?
Yeah. Yeah. What equation does that look like?
Y equals mx plus b. Sure.
Y equals mx plus b. Look at Kinsey getting it.
Yes.
I'm getting
And
it.
that is what? The equation of a line, right? A line is a function. Right? Make sense?
Yes.
Okay. Some of the hints that we see, in this scenario, your y is a function of x. Okay? Remember we said y is a function of x. Okay? Now, but look at B. We actually have like x being a function of y in this scenario. Do you see what I'm saying? We've got x equals something. Does that make that a function? No. Okay. More than likely, that function is gonna, or that graph is gonna look something like a big C, right? Open to the side. And do you guys know that when you look, if you draw a line down, if it hits twice, not a function. Okay? So it's no. Okay? Questions, comments, concerns? Got it. You guys are jamming. That didn't work. Rock out.
I have a question.
Okay.
I just don't know how to
Okay.
ask. So there's a negative under that negative half. And
Yes.
then the y on the graph is also negative. Will negative positive ever be remote? So y would not be a function.
The negative, no, actually that negative actually means that your graph of that line is going to be like that. It has a negative slope, but it still makes it a function. Okay. What's going to make this not a function? If I try to solve for y, I'm going to end up with a plus or minus because of the square root sign. Okay. So if I look at that, I'm going to have x minus 1 equals 2y squared, right? X minus 1 over 2. the square root of that is what y is gonna equal, okay? When I take the square root of something, I have to take the plus or minus. That's giving me two answers, right? One for the plus, one for the minus. That's why it's gonna be not a function, okay? So it has less to do with the actual signs of the numbers. Does that make sense? Okay. Yes. Oh, okay, because that's yours. Okay, next slide. I'm like, why is it not clearing? Because it's not what I wrote. That's fine, everything's great. Okay, box. Sometimes it's helpful to think of function f as a machine that receives an input from the domain, does something with it, and then outputs a value, okay? So we can say here we've got like a pipe, something comes in, something happens, something goes out, okay? It only accepts numbers from. What numbers for x can I put in here? What is x allowed to be? Starts with the letter D. Domain. Look at y'all go. Okay. Your x has to come from your domain, right? Because that's where x comes from. For each input, we're talking a function. So for every x, there is only one output. Okay? So there's exactly one output. Okay, exactly one output. Okay? For a function y equals f of x, the variable x is called the what? What kind of variable is that? Do you remember that? You got two choices. You got independent, you have dependent. Which one? Independent. I think I spelled that right. I'm not really sure. Because it can be assigned any value within that domain, right? Okay? So it's independent. I can pick whatever I want, as long as it's in that domain. Now, the variable y is then which one?
Dependent.
Dependent. Because it depends on x, right?
Yes.
My y is going to be completely different based on my x. So your y depends on x. It's dependent. Make sense? Yeah? Okay. Next. Look at that. We got it today. We're like on it today. Okay. State the name independent variable and dependent variable for the functions below. So, A, what is my independent variable? What, yeah, I was gonna say, what did we just say? It was x, right? Now, I plug x in and I get what?
Excellent.
No. Pull that out of your butt?
Yeah.
Okay. I'm like, x squared. I don't even. Okay. If I pick any x, what am I getting out of it when I put it in there? You said it before. G of x. Okay. Or the y. Okay.
About 30 minutes, take it out.
Oh. I thought you were going to a lot less time than that.
I thought so.
I'm giving you a hard time. Okay. So the second one, okay, very similar. We're calling it f of x. Which one's my independent? X. Which one's my dependent? Oops. Since I wrote it on the board already, it's fine. My y is dependent. Up here. Por favor. And we are on the back of the bottom of the back of page 1. You're welcome.
You said the x is independent and the y is dependent
Yes.
for the first two, or for the A two?
Yeah.
Okay.
Because we're still using x and y.
Wait, can you repeat that again?
Your x is independent. Your y is dependent.
So f of x would be dependent.
Okay. Yeah, your f of x is the independent. So here on C, okay? We don't have f of the business as x's and y's anymore, right? So what is my independent variable? What's the one that I can put anything in for? In. Very good. What is my dependent? Not R. P. Because P equals n squared, right? So I can pick any n I want, and I get P out of it, right? Remember, we talked about that little machine, right? I'm putting n in, I'm getting P out. Do those make sense? Yeah? Okay. Next page. Okay, example 4. Top of the second page. Here we go. Okay, I have a function defined, minus 3x squared plus 2x. Okay? What is f of 3? How do I figure that out? Right. Equals, what do I put?
3 times 3 squared.
It's minus 3, but yeah. Would you like that? Now what?
What's 2 times 3?
Yeah, perfect. Okay. What's 3 squared?
9.
9. What's 9 times 3? Yep. Plus, what's 3 times 2? 6. That look right? Minus 21?
Yeah, that's the point, right? You just plug it in, right?
I just plugged and chug.
Okay, I'll make it.
Plug and chug.
Plug and chug, baby.
Oh my goodness, she's got a kitty cat. I got a kitty cat. How cute. Okay.
Stop the picture. Yeah.
Let's do B over here somewhere because I write big apparently. Okay. F of x plus f of 3. What?
Can you do that one again?
No.
Hey, please.
Why? It's right there.
Yeah, but I can't like, hey.
It's just your butt up here.
No, I can see it. It's the right behind it that like throw me off.
Minus 3 times 3 squared
Okay, I got that.
plus 2 times 3. Okay. Equals negative 27 plus 6.
Okay, that's right.
Okay. Which equals minus 21.
Okay.
Okay. F of x plus f of 3. So what's my f of x? X squared plus 2x, right? What is f of 3? Minus 21. Easy peasy, right? We just combined a and the original f of x and got negative 3x squared plus 2x minus 21. Make sense? Yeah. Yeah. Okay. Okay, let's do C. F of negative x. What am I going to do?
I don't know.
Mary Mac, I don't know. She said she goes, I got no clue. Okay, f of 3. What did we do for 3? We took 3 and we put it where? In for x. If I want to see minus x, what am I going to do with the minus x? Put it in there. Okay? Minus 3 minus x squared plus 2 times minus x. Okay? What is a negative times a negative?
Positive.
Okay. There's 2, so it basically goes away, right? That x, that minus sign in front of the x. Okay? What about that one? Negative minus 2x. Make sense? All we did is we took whatever they put in the parentheses and made x equal to that. That's all we did. Okay? I'm gonna get rid of some of my chicken scratch so it helps out a little bit. D over here, minus the function. What am I gonna do here?
Flip all the signs.
Look at you go. Okay, because I'm gonna do minus, right? Hold on, kids. Minus 3x squared plus 2x, right? Do my little humps, right? So it's gonna come back and say, what's a negative times a negative?
Positive.
Positive. And then what's a negative times a positive?
Negative.
Okay, 3x squared minus 2x. Do you see the difference in what we did between C and D? Here, for C, the negative went with the x, right? Because it was inside the parentheses after the little funky f, right? Here in D, it was actually associated to the function. So we gave it to the whole function. Does that make sense? Slight difference. Okay? F of x plus 3. What do I do?
Plug it in.
Plug it in, plug it in. Y'all, I watch too much TV. X plus 3 squared, right? What comes next? Plus 2 times x plus 3. Easy peasy. Okay? Whatever's in that parentheses, you put it in for x. Right? That's all you do. Plug it in, doesn't matter. Okay? You can go and distribute. You guys know how to do all that? Combine like terms. You can all do that. We're not gonna do that here. We got other stuff we gotta do. Sound cool?
Yeah.
Yeah? Okay. Any questions?
Yeah,
Yes, ma'am.
okay, so.
Oh, yeah, I forgot about you, Kenzie, sorry.
2D graphics deals with manipulation of flat images, and 3D deals with manipulation of virtual scenes.
Yes.
Okay. Like, I'm doing my homework, I'm almost done. Wait.
She's doing homework for her other class. It's fine.
Yeah.
I'm gonna beat her with a stick later. It's fine.
At least I'm doing it.
That's not, you're not wrong. Not
Hey,
wrong.
this is improvement.
I will take any little benefit I can take, okay? In general, when a function f is defined by an equation with x and y, we say that f is given implicit. Okay? If it's possible to solve the equation for y in terms of x, we write y equals f of x and say that it is explicit. Actually, it's explicitly, knowing my terrible English. That's okay.
What's that first word?
Implicitly.
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 Implicit. I can't say it.
Do y'all know what the word implied means?
So why?
When you imply something?
I don't know what it is.
You don't know what imply means? Imply?
I do.
Okay.
I am.
Implicit is related to the word imply.
To strongly suggest.
To strongly suggest. If I'm saying it explicitly, I'm telling you it's 4. You don't have to guess it's 4.
Yeah,
Right?
I do that.
Rock on. Okay. Yeah? Okay. Wait, I can't. Well, you weren't doing your homework in the other class. Or was that you that yelled? No. Oh, I'm sorry.
I'm sorry. I'm sorry.
Okay?
Oh, I totally thought that was wrong.
That's okay. One more example, example 5. We're not doing too bad. Okay? So we just said implicit and explicit, right? What we want to do, so we've got these functions here. These don't look like how we've been seeing them, do they? I've got 3x plus y equals 5. Okay? Is that going to be implicit or explicit? In.
I just guessed.
Because you have to solve something, you have to go find it, right?
So that's implicit.
That's
You
implicit.
gotta go find it.
Okay? This one right here, y equals f of x, which equals something. Is it just flat out telling you what it is?
Yeah.
Yes. Explicit. Oops. Does that make sense? Okay. Now, I can take this first one, 3x plus y equals 5. I can make it explicit, can I?
Mm-hmm.
Y equals 5 minus 3x. Guess what? I'm explicit now, right? I went from implicit, implied, right, to explicit. I just flat out told you what it means. That make sense? Yeah? I'm waiting for the basketball team to catch up. I'm just saying.
Pretty good.
You all got it? Okay.
Good. We're smart.
Yo.
I can't withdraw. Next. Okay. Box at the top of the next page. The difference quotient. Okay. On your quiz, I think last time, they actually gave you what the difference quotient was, so you don't need to memorize it, but what it is, and you can write this on the line, but it's, I write big, so I'm not looking. F of x plus h, do y'all remember this kind of ish?
Yeah.
Minus f of x divided by what, you remember?
Nope.
H. H, okay? H cannot be equal to what?
X.
0. Why?
I can't divide.
Yeah.
You can't have a 0 on the bottom. Not a thing. Okay? So yeah, f of x plus h minus f of x all over h, where h cannot be equal to 0. Okay? Make sense?
Yeah.
Now, with all the stuff that we just did in the previous slides, we can figure out all these pieces, right? Even very much, yeah. I'm so impressed.
Ooh.
Okay, let's do some examples.
Mm.
She's not so confident anymore. Okay. F of x plus h minus f of x divided by h, okay? If my f of x is minus 2x plus 1, okay, we're on the one on the left-hand side here. Okay? What do I do first? F of x plus h. What do I do with x plus h?
Plug in x plus h where x is.
Exactly. X
Yeah.
plus h
Yeah, boy.
plus 1. Negative 2 parentheses. X plus h parentheses plus 1. Okay? Yeah? Yeah? Okay. Minus. Now I'm going to put a big parenthesis around there because we got more stuff coming. F of x, which is just writing it again, minus 2x plus 1. Okay? Does that make sense? Yeah?
I can't read that far.
Can't read that far.
No.
I'm writing huge.
I'm blind.
Just saying. I'm going to ignore the divide by h for just a second, okay? Because I want to deal with the top part first. Okay? I just got to remember to put it back later. So, take my minus 2. I can distribute that, right? Minus 2x plus minus 2h, right? Or minus 2h. Yeah? He's right in the background for Zoom. Sorry.
That's
Hold
plus
on.
2, that's plus 2h? Or minus?
Hold on. Go on. There we go. Negative 2, x plus h, plus 1, minus, the original function, okay? Minus 2x plus 1. Does that make sense? Does that help? Good? Okay. So we took the minus 2 and we distributed. Okay? Plus 1. Don't forget the plus 1. What do we do with that minus sign? Distribute it. Very, very good. Minus and a minus is a, right? Minus and a plus, minus 1.
That's everything.
Okay? Make sense?
I have a question.
Yes, sir.
So, like for that top one, like the negative f to the right side, how do I know it's a negative right there? Like plug that in.
Because my formula is f of x plus h minus f of x. Right here.
You just get rid of the F.
Hmm?
Like, you don't have to do anything with the F. Like, I thought you had to
With
plug
the
it.
f, which f? This f?
Yes.
No, that's this part right here.
Okay.
Right? Minus 2x plus 1, that's what f is. Right? Does you see what I'm saying? And so we distribute that minus because of that. Make sense?
Mhm.
Cool. Yeah, 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 yeah. Y'all, my life. Ta-da! Okay, we did it. Okay, let's combine stuff. Can we combine stuff? What can we combine?
X's.
We got -2 and +2, right? What's a -2 and a +2?
Zero. So it cancels out.
Those cancel out, right?
We're left with
What about +1 and -1?
cancel out.
Those cancel out. So what are we left with?
-2H.
Yeah, there we go. -2h. What did I say we had to come back and do later?
Over H.
Henry, no, we're killing it.
You gotta stop scaring me.
Now what can I do? -2h over h. Cancel out the h's. Okay? So what's my answer?
-2.
-2! All that for finding -2. Does that make sense?
Yes.
Yep.
All we did is everything that we just did before, we plugged it into that formula with whatever it gave us. Okay?
Correct.
Okay. I'm gonna leave B for y'all to be able to do on your own because it's the same thing.
Hey.
Okay? So let's see. The domain is the set of real numbers for which f of x is a real number. In other words, it's the set of the largest, oh God bless. The domain of a function is the largest set of real numbers that produce real outputs. Okay? When I say real outputs, what's the opposite of a real output? A non-real. There you go.
Yeah, thank you.
What would be a fake? Divide something by 0,
Yeah.
right? That's a fake,
Yes.
right? What else is a fake? If I told you that, what would the fake be? What cannot be inside of that?
Zero.
No, you could do 0.
You can square with zero.
You could do square root of 0. 0 times 0 is 0.
Negative.
Jeez.
I said that first.
No, you didn't.
I said that first. I swear.
Yeah.
I said-
Okay? Can't be negative. So those are my fakes.
said that.
Okay? So when I say the domain
She's
of a function is the largest set of real numbers that produce real outputs, it means it has to work, right? Somewhere along the line, we learned that the square root of a negative is like some kind of imaginary thing, right? We're not dealing with that right now. We don't do it. It's just not real. Cool? Okay. Steps for finding the domain. What would you start with? Ladder of death.
Maybe finding a
Yeah, well, that's the whole thing that we're doing is finding it. But what would I start out with? Just like start out with everything, right? You start out with the set of all real numbers. Okay? Negative infinity, except that look like more like an 8 or to infinity. You start with everything, right? You're going to start with everything and you're going to subtract. Okay? You're going to start taking numbers away. If the equation has a denominator, right? What does that mean? Fraction, right? Exclude any numbers that what? What do we say it can't? What can the yep. The denominator cannot be 0. We just said that was a fake. We can't do that. Right? Why do we exclude them? Not enough. Right? Okay. If the equation has a radical of even index, okay? what they're saying, technically, we know that this square root is an implied number too, right? Do we know that?
Yeah.
I think you're lying. That's okay. Okay, square root of 4, or I'm sorry, cube root, no, what's a 4? 3 is a cube, what's a 4? Fourth root? Quarter root? Okay. What they're saying is if this number over here is even, whatever goes with that radical sign, okay? Exclude any numbers that cause the radical to be what? What did we say? Negative. Very good. Does that make sense?
Yes.
Start with everything. Get rid of the two things we said don't exist. 0 on the denominator and a negative inside your radical. Yeah? Am I on your way? The word down there is negative, sorry. Okay? Again, it asks us why, but we already said why. They're not real, it's not a real thing. Okay, so it doesn't exist. Okay, let's go to the next slide. Let's do an example or two real fast here. So, A, we're going to start with all numbers, negative infinity to infinity. What's the rule that we're going to use for that? You have a fraction, so what is it going to be? What can't be 0 in a fraction, y'all? The denominator. Yeah, x squared minus 2x minus 3 cannot equal 0. Okay? By factor, can I don't think I can factor that. Maybe I can, I don't know. I don't feel like it, I'm not gonna lie. Okay, so it's for all real values except where that equals 0. Okay? What about the second one? B, g of x equals x squared minus 9. We start out with everything. Do I have a denominator here? No. Do I have a square root here? No. So what am I left with? All real numbers. Okay? So if I'm using interval notation, okay, negative infinity to infinity. Okay, that's everything, right?
I just do.
Oh, you good?
The subfield of computer graphics that involves producing images. of
Anyway,
virtual
next.
worlds is called
Okay, I've got a radical here. I'll tell you later. We have a radical here. What can my radical not be? Negative.
Uh-oh.
So-
Negative.
3 minus 2x has got to be greater than or equal to 0. Right? Otherwise, it's going to be negative and it's not a thing. I can solve this, right? My terrible writing. Right? And then you can just solve for x. So I've got x must be less than or equal to 3 over 2. That's all there is to it, right? Start with all reals, look for denominators, look for radicals. That's it. Yes, sir.
In parentheses, what would that look like?
In parentheses, good question. X is less than or equal to 3 over 2. Where am I starting at?
Brackets?
Okay. What kind of brackets? Well, what's the number I'm going to start at? Or number or symbol that I'm going to start at? If it has to be less than. What is it?
It's a negative infinity.
Correct. If I have a negative infinity, what kind of bracket goes in front of it? Yeah, parenthesis. Always, right? Because you can't ever get to infinity, so it can never be equal to that, correct? What number do I have? 3 over 2. Okay. Do I have my equal sign? What does that mean? What goes there? Square bracket. That's what that looks like.
Thank you.
You're welcome. Yeah? Are things clicking a little bit?
They're clicking.
I'm not talking to you, Mackenzie.
Alright.
You're not my friend right now, but
Alright.
that's okay.
Oh, your coffee is so good.
It is so good. What was your question for first?
The subfield of computer graphics that involves producing images of virtual world is called
I put it this way.
What are my choices?
nothing.
I don't have choices?
No.
I don't remember. I ain't gonna lie.
Is it rendering?
Yes, I think so. Okay, next slide. Okay, so on that page is marked page 21. We don't need that first part, okay? With the box and the example 7, so I X'd it out. Yes, sir.
I gotta go.
Go for it. Have fun. Yeah, I think this is gonna be our last little section anyway, and we'll pick up with the example tomorrow. Cool? Cool. So we'll fill in this box and we'll pick up with the example tomorrow, okay?
I'm getting my work done.
Okay, the difference F minus G is defined by F minus G of X, right? How do I find that? F of X minus, let's see, G of X. Okay? My domain is going to be equal to what? We've got two functions.
She ain't gonna tell you no.
I ain't gonna tell you no, you're a grown man.
They're not trying to learn this, did you? They're not one that type of learning.
I know, it's fine, I've seen their grades.
Is that minus, is that F of X minus G of X?
Yes,
Where?
F of X minus G of X. Marcos knows I love him, it's fine. Okay, the domain. Okay, it's gonna be it's gonna be the domain of F. The domain of F, where it intersects with the domain of G. Okay? So whatever your domain of F is, and whatever your domain of G is, it's everything that's common between those two domains. Does that make sense?
Domain of F intersect with the domain of G.
I don't get it.
What's written on that bottom?
The domain of F,
Is that what you just said?
yeah, yes, it's fine. The domain of F where it intersects the domain of G, okay? So you take the domain of F and the domain of G and you compare them. Every place on those two domains that match, that's gonna be in your domain, okay? For example, if my F of X has a domain of all real numbers, right? My domain of G says I can't be equal to 2. What's my F minus G gonna be? All real numbers minus the 2 that the other one can't be, right? So it's gonna be all real numbers except for X cannot be equal to 2. Okay, does that make sense? No. Okay,
That's fair.
my F of X is gonna be equal to 1 over X. Okay, what's my domain on that? X can't be what? 0. Right? If I have G of X, what's my domain of that?
Oh, can be anything but 0.
Anything, right? This is all real numbers. Yeah? If I were to subtract F of X minus G of X, I basically combine those two domains, right? So it's going to be all real numbers except for when X is equal to 0, can't be equal to 0. Because then I make my F not a thing. Make sense? No. Okay. We're almost done, I promise.
This is the.
Okay, the same thing goes if I add them. Okay? F plus G of X equals F of X plus G of X. Okay? That's all it is. Okay? Let's skip down to the product. F times G. F of X times G of X. Y'all see a pattern here? Y'all see something going on that makes sense? It's just the same thing. Okay? F over G equals F of X divided by G of X. Okay? Does that make sense? Are you okay, Jessica? Oh, okay. That better? Okay. So if you say add two functions, you just take the two functions and add them together. That's what we did before, right? If I say subtract, I just subtract the two functions. Whoops. Okay, that's what I did before.
You can do it right
Do what?
there. I thought you were about to go on.
No, I'm not going on. I may fall off this stage though. Okay? Do you kind of see a pattern going on though? You know, you go on to add, subtract, you subtract. You want to add, you add. You want to multiply, you multiply. Divide, divide. What do you think happens to those domains? Anybody? Nothing. Okay? So the answer for this one up here is the same for that one, right? And it's the same for that one. Okay? There we go. Old lady, it's fine. My old lady sounds great.
When you say nothing happens to them, does that mean like don't simplify them?
No, all I'm trying to say is the domain of F, where it intersects that domain of G, it's always that same domain of F intersecting domain of G, whether you add, subtract, or multiply.
Okay.
That's what I mean. Okay? One thing happens when we divide them, though. Look at what we're doing. We've got a fraction. Okay? So we're going to take the domain of F, intersect it with the domain of G, but we have one more thing we have to check. We have a fraction. What do we have to check? What don't we like on fractions?
Zero.
Yeah. So for this one, it's the same, plus G of X cannot be equal to 0. That's a terrible 0. Okay? So you have one extra little check to do if you divide two functions. Okay? You're still going to have the domain of F and the domain of G, okay, where they intersect. But then you also need to do a second check to see where G of X is equal to 0. Because what that's going to do is that's going to give you a 0 on the bottom, and that's not legal, that's illegal. Yeah? Yes, sir.
For the domain of the first one, say domain F and,
Intersect.
Intersects.
no, I'm off of the second one.
It says the exact same thing as the first one.
It's an intersection. Huh?
Domain F intersecting domain G, it says it here, it says it here, it says it here, it says it here.
Okay,
All four of those lines say the same thing. Okay?
thank you.
For minus, plus, and multiply, you can stop. Divide, you got to do one more thing. Make that bottom not equal 0. Okay? So you're going to have that added little baby step of making sure that that G of X is not equal to 0. Questions, comments, concerns? Negative? Okay. Was this helpful?
Yeah.
Perfect.